So we finished our first section of modeling. There will be some more modeling techniques in the end of the course, but for now we will focus a little bit on textures. And I think this is the right point to explain you the rough concept of parallel noise and Voronoi diagrams. So we use parallel noise in Touch Designer before to do displacement maps, and in this session we will use it in Blender directly to generate some textures like this, for example. And history of noise is that it was developed for the movie Tron in the 80s by Ken Perlin. Later Ken Perlin also developed simplex noise, which is a more efficient way to calculate noise. And the main idea is you can calculate for one dimension, like here, 2 dimensions, 3 dimensions, and it's even possible 4 dimensions, but it's not actually 4 dimensions, you just have one more parameter. But that's not super important right now. So you take a bunch of points and you distribute them over a x and a y axis, and then every point gets a random direction vector. And on this direction vector you put a gradient, and in the end you just blend all the gradients together. Let's watch this in Touch Designer for a second. So this is basically this. We just have a bunch of gradients and then we interpolate between them, which means that we put a blur effect on everything. And if you put monochrome off, the gradients are not black-white, but you just have a random color assigned to them inside of the RGB color range. Yeah, you can also calculate this with 3 dimensions, where you just distribute the single points not on a 2D plane but in 3D space. And the next concept we're talking about is Voronoi. In Voronoi we also have a plane and we distribute some random points on it, and then we calculate for every position on this plane which is the nearest point. Here we have a GIF where you can see a little bit better, and this concept was used in a lot of different scientific fields, like it was over and over rediscovered. I have a few examples in my book in which fields it was discovered, and yeah, this over here is probably the first Voronoi map. It was not titled as Voronoi, or neither were the mathematical concept behind it explained, but Descartes had the idea that there are vortex streams around stars, and it's basically the same concept. You have a star, which is the random distributed point, and then you look at the space, and every point, like every position here, is closest to one star, and therefore you can calculate the patterns. There are multiple ways to calculate these distance. This is the Manhattan way, this is the Euclidean way. Mostly we will use this one in Blender. And yeah, like there's a noise node and a Voronoi node in Blender. Both are very powerful, and we're gonna look at them today. So let's start with a sphere. And let's go right into shading. Let's create a new node. Let's start with noise. We have the vector, and there's also color, but we're gonna work with the vector and a 3D space. So what I will do now is press Ctrl T. This is happening. This will not work for you. You have to go to Preferences, Add-ons, and then you check for Node Wrangler and you activate this. And it's not the right order to explain it, but it's better for the workflow, so we're gonna do it right away. I create an empty, and now I take the text set coordinate from object and plug it into vector. Now I take this and I choose the empty. And it's the same concept we had with the displacement. If I take, move it, I can scale it. Yes. So let's make this a little more interesting. First, we're gonna go for a color ramp, plug it in here, and then you check for bump. Bump and normal naps are kind of a big topic, but I will not go into detail. There is a complete chapter in my book if you're more interested. So plug the vector into the height and then plug the normal here into the normal. And we're gonna increase the contrast, and now you can see all the deep points are dark and the high points are white. And of course we can play around with these colors a little bit. And what I always like with these textures is remove the roughness, make it a little bit more specular, and add a little subsurface like 0.4, and now you got that really gross skin texture. I will deactivate it now, because now we will look into Voronoi. It's not important for that. So we take again our vector here, plug it into the vector, and we don't have a vector, but we have a distance. So let's take this distance here and here, and you see we have that random distributed points and then the fields around them, and I'm gonna change this from F1 to smooth F1. And you see we have these artifacts here. Okay, so here we have Euclidean, here is the Manhattan one I showed you before. It's not working for this topology, so you can play around with all these things here. It's up to you. I want to show you a few more settings in the noise. Let's try to recreate this one. I'm gonna pitch up the distortion. Yeah, that's kind of it. Let's add the subsurface. Less. Okay, so I think the rest is lighting. So what I did just was to add the subsurface scattering. I talked about it in the past lesson briefly. It's that concept of semi-transparent objects. And here you have a subsurface color. So this is the color from the object on the outside, and at the inside right now it's white. You can also turn it green, blue, and yeah, if you experiment with this, there are a lot of ways to get some cool results. So we created our material, but it's only in this file, and it would be nice to use it, for example, on our displacement figures. So what we're gonna do next is save this material, so you can also upload it for other people to our cloud. I'm gonna make this bigger, and we're going to the asset browser. It's important you have at least Blender 3.0, but I think you all have the newest version. And what we're gonna do now is we go to the material tab, we choose our material, which I call procedural noise, right click, mark as an asset. And right now we have that current file, and this material is now current file. To make it globally accessible, you go to Edit, Preferences, and then down here on File and Paths, you can add multiple paths to asset libraries. Let's just add a new one. We are at tutorial 3, and we're gonna create a new folder and call it asset test. And we're gonna call this library also just test. You can close this, and now you see you can choose this. To make the material accessible, we have to save our file with the material into our asset library folder. So I'm saving it here, and now it's showing up here. Not here, because you see this one is empty. If we take this one, remove it from here, zack. Here we go. So I opened my file from the last tutorial. I want this to be a little bit brighter. And what we're also going to do for a nice preview is, let's disconnect this. Like I changed here from, like you go to shading and then you change from object to world. And it's basically the same as this one, but with nodes. And now we can add an environment texture. And we add HDRI. I'm gonna talk about HDRIs in the next lesson, but just Google HDRI and you'll find a bunch of free ones online if you're interested. Yeah, so basically it's simulating a lighting from this environment here. We're gonna use a lot of techniques with the world node editor later. And now I can just switch between them. So let's go to our asset browser. And you can just plug it over. And it imported also RMT. Okay, very nice. There will be a second tutorial this week. I recorded it with Antonius and we're gonna talk a little bit more about handmade textures, like self-made textures. And for that, I need to warn you a little bit because we're gonna use cycles, and cycles is much more heavy on your computation force. So try following the tutorial and then give me feedback how well your computer did handle it. Because Eevee is faking lights, like there's no physical calculation in Eevee, but cycles is based on ray tracing. You can choose the GPU if you have one. And yeah, we're gonna talk about this a little bit more in depth later when we are coming to refraction of glass, because glass materials basically just don't work in Eevee. There are a lot of workarounds, but it's just not satisfying. Yeah, so again, you can move this, scale it, rotate it,